Good morning.
Good morning. Good morning. I'll get us started in just a sec. Hi, everyone. Yes, welcome. And yes, good morning. I'm here to back to pre-calculus on this Tuesday. It always feels so funny, though, that I see you all on Tuesday and not on Monday. It's hard, to be honest. I would rather see you all Monday so we have like a fresh start. But welcome, all. I'm happy we're all here. I am just making sure I'm letting all the folks in. But haven't yet. I went ahead and already posted these slides on Google Classroom. So if you'd like to follow along with us, feel free to open them. I will say though, today we have a Desmos activity. It won't be a group one, it'll be an individual Desmos activity. And it's gonna be for, that's what we're gonna be doing today. I'll get to it. So yay, let's get that credit. But let's first begin with a check-in question. April 13th today, y'all. April 13th is crazy. Okay. So, what's something you can do today that would just be good for you? What's something you can do today? And then hopefully it's something you could hold yourself to doing. So go ahead and think about what that good thing could be and put out there as we check in. I'll let y'all think about that. That's what we have. Let's see. We got eat and trying my best. I love that. Yeah, getting that nutrition in and trying our best. That's what matters. We have reading. My good thing will be taking a 2-hour nap after this class. Man, that's awesome, dude. I when I nap, if I don't put a timer, if I nap, I'm gone. Like 4 hours. I don't know. It's crazy. So I try to not take naps, but if you could take a 2-hour nap, that is great. We got do all my work and take a nap, eat healthy. Yes, eating healthy. I definitely, I got a salad that I need to eat. So I think I also want to say eat healthy today as well. We got sleep, read and getting enough sleep. Well, I like that there's a lot of us who like to read here. That's really great. Take a walk around my neighborhood. Yes, Miles. That's something I want to do. I need to get out and kind of maybe around lunch, right after this class, lunchtime. That's going to be my next break. So I'd like to walk around too. We got getting some sleep, eating, exercise, sleep, being confident in my work. Yes, that's something good that we could do today. Just being confident in our work, doing the homework. Do that homework. Drinking lots of water. I agree. Yes, drinking water. Right, Danny just said same. I can't do shorter than 2 hours. I don't know how people do a 20 or 30-minute nap. I do not know. For me, I feel like miserable because it's like I want to sleep more. Oh, okay. So you got portfolio class coming up. Try not to forget to do my homework. Yes. And don't worry, I could also send some reminders if you need some help. But yes, that's awesome. These all sound like really great things. I love the variety in this. We got like taking care of mental health. We got even doing something good as in being productive. We got some wanting to do some work, doing their best. I like the variety. Yay. Okay. We got, yes, finished my homework 30 minutes ago. I love that. That's okay. I appreciate it. Welcome, welcome if you just came in. If you could please answer the check-in question so that we can get you marked here. That definitely would help so that I don't accidentally mark anyone absent. Oh, thank you all so much for sharing. Let's see who we have and who we're missing, and please correct me if I'm wrong. But let's see, I'm gonna start from the top. So I am missing Denise. I'm missing Jirel. I am missing CJ, Carlos, Risha, Leon, Sincere, and Celia. If you're actually here and I messed up, please let me know. It happens. But I'm kind of skimming through who answered the check and I don't see these folks. So I think I got it. If you're friends with any of these folks, it would totally help to send them a text to remind them to come into pre-calculus. Let me give that the names one more time. So that is, I am missing Denise, I am missing Jirel, CJ, Carlos, Risha, Leon, Sincere, and Celia. All right, y'all. Yay, thank you so much for that check-in. Now I'm gonna go ahead and transition us. Okay. I love everyone's profile pictures, by the way. They're really cute. It's a very interesting profile pictures. Okay, so let's jump into our agenda, y'all. So I just took attendance. Awesome. We're going to be doing, so it's not going to be a group Desmos. It's going to be an individual Desmos lesson. So you just want to make sure you log in and answer each part. That way it can give you your full credit. And we're going to take a look at something called a radian today. It possibly a word you know, possibly don't know. Don't worry. It's going to be an introduction to what is a radian. Then we'll have an exit question. So as you can see, most of our time today will be focused on that Desmos lesson. A little reminder that our next asynchronous assignment, that's due tomorrow midnight. So there is time for that next one that's coming up for us. Or I'm sorry, I think it's number 8. I think, yeah. Ours is it's number 8. That's next, and that one is due Wednesday. So let me know, does anyone have any questions about what's happening here today? Questions, concerns, or anything about the async work? I'm happy to address that. I'll just pause here for a bit for us. Okay, friends, let's jump into it. So before we get started, just a little bit of a verbal recap. Usually I have a little visual recap, but yesterday we started off the first day of class. Was that yesterday, yo? No, I'm sorry. That was last week. Thursday was our first day in pre-calculus. And we had started out by reviewing and talking about what is trigonometry. And I also finished up my math story of when I was in college. So that's kind of like where we're jumping off from, and we're continuing. So today we have something new that we're learning. It's going to be a Desmos lesson, and here's the learning target. I can explain what a radian is and relate a radian to degrees. So that is the learning target. I'll let you read that. Maybe think about what are terms you don't know and what's new to you as you're reading this. Yeah, me too. I thought that was yesterday too. Time is crazy when it's distance learning or working from home. It's like sense of time just gets all mixed up. Okay, awesome. So that is going to be what our Desmos lesson is going to be about today, everyone. But before we jump into the Desmos lesson, I do think it's going to be worthwhile to review with you some geometry terms. So think back to your 10th grade selves somehow. Here we go. So a little bit of review. Don't worry. So this is pretty entry level. So things we should know are words like circumference. So the circumference is basically like the length of the line that makes the outer circle. Think of it like the perimeter, or you could think the circumference like if you have a string length and you just wrap it around into a circle, whatever the length of that string is, that is your circumference. So circumference is a term we should know. Another thing, notice it's circles. So we're going to be looking at circles today. Another thing is every circle, of course, has a center, and every circle has what we call a radius, which is the line that connects to the circumference from the center. The radius is going to be the same all around the circle. So always the same. That's why when you were in geometry class, you were able to draw circles using, what do you call that? A protractor, I believe, that thing that spins like that and you make your circles. That's possible because of the fact that the radius is the same all around the circle. Not only that, but there is a special property in circles. The circumference of a circle, the circumference, the length of this outer perimeter of a circle depends on whatever the radius is. Specifically, here's the formula, y'all, down here. The circumference of a circle is equal to, and here's the formula, 2 pi r, where r is your radius. Basically, you would just plug in whatever your radius is, and you would get the length of your circumference of your circle. And let me see the chat here. Oh, we have Miss Lauren left this year, right? Or was it last year? My goodness. I think Miss Lauren had left at the end of last year, but correct me if I'm wrong. Um, I think it was at the end of last year. But yeah, that's true. Yeah, yeah. Cool. So I guess that was correct. Even though it's not cool. I mean, everybody loved Miss her. I have her on Instagram though. If you guys don't, I think she has an Instagram that y'all can follow too to keep updated. Um, awesome. The next and very last thing that I think we should know before we hit our Desmos lesson together is this thing called arc length. Arc length is, I like the visual picture, to be quite honest with you. Uh, here's what an arc length is. It's kind of like a portion of your circumference. That's your arc length. But usually your arc length is is kind of pizza sliced by an angle. Let me give you the formal way we say this in geometry though. This is called subtended by an angle. We call this formally. But I like to think of it like it's pizza sliced, and this is the length of the crust of the pizza. That's how I like to think of it. But the formal term is an arc length is a portion of the circumference that is subtended by some angle. That is what an arc length is. So let me let you take a look at these terms we should know, process them, and if you're good, let's go ahead and jump into the Desmos lesson. Okay, let's go ahead and get to it, y'all. Let me show you. So prepare. So make sure you, if you're, probably it's easier to be on a laptop if you're on Desmos. So get yourself prepared here. So go to student.desmos.com and you're going to type in this here code. Let me give you all a minute and then I'm going to transition over to the Desmos and we'll check to see who we have in and then we'll get started, everyone. So let me give you a minute to log in there.
Do we not log in through Google at all?
Sorry, Google Classroom. My bad. I was getting my lip gloss. Anyways, nope. You just you don't need to go to Google Classroom unless you'd like to have a copy of the slides. If you'd like to like add in little additions, but quite honestly, you don't need to go to Google Classroom today. You're just gonna go to student.desmos.com and type in this code on Desmos. Pretty much. Great question. Oh, LOL. So I just got a clarification in the chat. So I think he meant if we sign into Google with Desmos. Yes. If that's what you meant, sorry, Danny. Yes. Do that because then that way it gives your full name. I do have some students who just put in their name instead of logging in with Google. Sorry about that. But either way, as long as I know who you are, you're good. You don't have to log into Google, but if it's easy, you could do that too. My bad. Okay, let me stop my timer and let's get to it. Let me just go ahead and jump over to the Desmos with you all. So I have it over here. And we got about 14 of you in. So I have, sorry, we have a few more folks coming. And I understand that some of you are perhaps, getting on your laptop, but we have AJ, we got Ruben, we have Sam, yeah, Miles, Brenda, Danny, Jasmine, Sincere. Rosario, we got Rebecca, Tori, Risha, Brandon, Gerardo. So we're at 15 now. If your name is not on here, please make sure you get on in here. This is for credit. Um, and it's also for credit if you want to just make sure you add in your little 2 cents here whenever there's a question. That would be awesome. Okay, we have I need the code. So let me just do this. And what I'm going to do is I'm going to just grab that and stick this in the chat. Yes, my friends, let me put the link right here. There you go. So go ahead and get logged in. Yes, we got 16 more folks. We wait a little bit to get us all in. All right, all right. So if I didn't see your name there, I just went ahead and sent you a little private message to make sure you get your credit. Yes, we got about 19 of us in here. So again, if your name is here on my screen, then you're off to a good start. But now your next thing is just make sure that you answer each check in here. So great. Let's go ahead and jump into what you could see. So I'm going to go to my student mode. This is what you see as your first slide here, which is the Desmos lesson and the learning target once more for you. I'm going to go ahead and move us to the slide number 2. So we're all going to bounce over slide number 2. So what I have for you here, don't be scared. So this, what you see right here is something called a unit circle. That's what this here circle is called. This is new, right? Perhaps. If it's not new, that's okay. It's new now. And we're going to be doing notice or wonder. So what do you notice or wonder here, right here, if you look at this unit circle? And let's just put our notice and wonders in the chat and then we'll try to, yeah, right? It looks scary, but don't worry. We're going to break it up and we're going to talk about it. So for the moment, just start to kind of analyze what you see here and just put a notice or wonder. So let's just start off nice and easy. Notice and wonder. Something called this unit circle. What are some things you're noticing and or wondering about? Go ahead and take about a minute and then we'll check in on the notice and wonders. Yeah, let's put that in there. So that's a good notice. Somebody message right now, various angles. Yes, that's a good notice. Very various. Yes, go ahead and stick that there into the, so some of you are sending me your beautiful notices and wonders. Make sure you put that right here, you know, where it says share with the class. So one thing that was mentioned in my direct, oops, I can't type it since I'm the teacher. I wanted to put it in. Oh yeah, somebody said various angles and notice degrees. See, those are awesome notice and wonderings. Is that how you spell various? Okay. That's me. So I guess I can join as a teacher. There we go. Go ahead and the rest of you, go ahead and enter in your thoughts and let's check in about a minute. So I see a few of us are still typing out some notice and wonders. Let me give some space for that, and then we'll take a look at what you all noticed about this. All right, everyone. Go ahead and finish up your notice and wonder. I was just making sure I read deeply what y'all were thinking here, and I'm going to point out a few of them. The everyone's notice and wonder is obviously very correct, very on point. I agree with all of them. The fact that there is a lot of angles, a lot of degrees. So a lot of you notice these angles like 0 degrees, 30 degrees, 45 degrees, and it's all around this circle right here, right? And not only that, but a lot of you are noticing the different fractions that you're seeing here. So the different fractions, noticing that there's these square roots right here. The numbers in the parentheses have these square roots. I like how someone mentioned down here Walter. So I went ahead and I anonymized our names, everyone. But Walter said, notice how it kind of looks like a clock, like with degrees, noticing that there's pi, that they're squared, wondering what the outer layer dots do, and why is the circle divided into four sections. So there's like these four sections, one, two, three, and four. Basically like the first quadrant, second, third, and fourth. That is a good question. I wonder that too. There's a lot of mention about the fractions. Marjorie's comment says, I noticed that there is a pi number slash equation for every degree there is. I wonder why there's so many numbers and equations. And let me also make sure I skip um, down. Another Jean was also wondering about those red numbers. Again, the pi symbol is coming up. And then there's fractions. So I want to just go back up to our unit circle here. So the pi numbers that was mentioned right now, right here, the ones that are in red, they're kind of color coded as red. And a student just right now noticed that these pi numbers that are in red corresponding to like a degree measure, right? Y'all see that? That's what that student noticed. And I see that too. Notice that. It's interesting, right? So they do correspond, and some of them are, most of them are in fraction form. So the reason why I'm pointing out these, some specific students who notice this is because that's going to be today's lesson, everyone. These numbers that you see in red here, y'all, these are called radian measures, and they do have a connection with degree symbols. They do have a connection. And before we move on, right? I'm going to just point out the fact that, when you go all around a circle, right? Like you start from 0 degrees and you go all around, you make a 360-degree circle. Notice how 360 is corresponding to this 2 pi radian measure. I just want you to keep that in mind because that's going to come back up later in our lesson here today. Let me know if anyone thinks I should point out anything else. But other than that, that's going to lead us into our next thing. We're going to be talking about these here red numbers, the numbers that have a pi in them. And we're going to figure out today what they are and what they mean. Let me see what's in the chat. Oh, okay. So another notice we have here that Danny put in the chat is they skip 30 degrees on each division. So they skipped 30 degrees on each division was um, something that was noticed. Or I think I feel like 0 to 30, and then 30 to 60. And I think from 30, yeah, I think if that's what you mean, I could see that pattern. Awesome. Okay, y'all. Let's go ahead and learn what these red numbers represent, this radian measure. I'm going to take us to the next slide, slide number 3, everyone. All right, so this is what you see as a student. It is my slide. So the what? Sometimes when we talk about rotations, right, we like to describe stuff using degrees. Degrees actually comes very natural to us. It even comes up in our conversations. Like, I don't know, there's doing a 360 in skateboarding. Or, when you change your mind completely, everyone uses this term. They're like, oh, they did a complete 180. You're talking about like they did like a 180-degree change or something, right? So angles come up naturally, even in our conversations. And we all kind of understand what 360 degrees means. You're going around a full circle. So it comes up, right? It comes up in their conversations. But even though we're so used to degrees, we're going to learn about another kind of angle measure called the radian. So that's the new thing we're going to learn. And it is related to degree measure or angle measure. And then, yeah, feel free to let me know if another way that degrees come up in conversations. The only one I thought about is doing a complete 180 and or some terminology in skateboarding. But that's all I could think of at the moment when I typed this out. Okay, let's go on to slide 4. Okay, y'all. So maybe some of you are thinking, if we love degrees so much, then why in the world are we even talking about this new thing called a radian? What's the point? Why do we need to learn this? What is wrong with just using degrees? And the best way I kind of like to describe this is with this visual here. And hold on, let me check the chat. Oh, really? The more you say radian, the more I start to remembering. Really? I mean, if you heard this before, that's cool. I do not what geometry did, honestly, but cool. Maybe it's somewhere deep in the subconscious mind. Anyways, why do we even do radian measure? So let's imagine this. Let's say I have some 45-degree angle, and I just have to kind of draw a 45-degree angle to kind of look 45 degrees. So let's say I have this. But then let's say that you want to describe how far a ball is traveling. It would totally not make sense to say, for example, let's say that this is about 45 degrees here. Let's say that the ball rolled about 45 degrees. Let's say that. Let's say that the ball rolled about 45 degrees, like this length here. Just imagine that. It would not make sense to describe to someone like, hey, the ball rolled 45 degrees, because you're like, well, what is that? Like, how do I measure? Is that inches, centimeters? What are you talking about when you say it rolled about 45 degrees? Like, we could kind of imagine what it means when it's like rotating in an angle, but what if I want to figure out the distance the ball rolled? So the reason why we want radian measure is because it relates more to the radius length of a circle, and it actually gives us an actual distance that we can measure. Think of a rolling ball. And that's why we need to introduce this new measure called a radian. Oh, that's okay. So Wi-Fi kicked you out. Let me know if anyone needs the Desmos link though, so you could join on, get your credit. Let me just pause and make sure I grab that once more. For some of you who are just coming in, let me get that link for you all. Yes, make sure you get your credit here today. So this is today's credit. As long as you're inputting your thoughts and all that, you'll get your credit. Let me know if anyone has any questions about the why. Why do we do radian measure? Again, so that we can actually calculate something like the distance a rolling wheel covers. There's actually many more applications, not just this, but this is like the most basic example I could think of to explain the why. Okay. Cool. I'm going to go ahead and move us all to slide number 5. We're going to talk about, well, what is a radian measure finally? We keep hearing the word. Well, what is it? Let's see. So here is slide 5, y'all. So let us start first off by looking at the first picture to the left. For the moment, disregard these, but if you can make already some mental connections, go ahead. But I'm going to start here on the very left-hand photo. Should I do red? I'm just going to do green. So let's say I draw a circle, right? My circle has a center like all circles do. And then I went ahead and I drew a radius length that connects the center to the circumference. Because radius length we usually call R, I'm going to call that R. Cool. So that's step one. I went ahead and I drew a circle with a radius. Step two. Now, what did I do here? What I did is I took this radius length, right, y'all? And what I did is I draped it on the arc of this circle, or I draped it along the circumference. I took the same radius length and I put it right here. And because I'm just taking this very same length and draping it right here, of course, the measurement of that red line is going to be R, just as my radius is. It's like I picked it up and I took it and I put it there. So that's step two. That's what I did next. Step three. After I went ahead and I draped this radius length here on the circumference of my circle, what I did next is I went ahead and I drew a line connecting back to the center of the circle from the circumference. And of course, y'all, we know that when it comes to circles, any line that connects from circumference to center, the length of that line is R. So whenever you have this property, that you have an angle that's extended, and this measure of the arc length is R, the radius length, as well as everywhere around you see R, that is what we define as 1 radian. This angle here is going to be defined as 1 radian. Whenever you have this this happening here, where you have R all around, that is how we define what a radian is, everyone. So again, the process was I drew a circle with a radius. I took the radius length and I put it on the circumference. Then I kind of created, I drew a line back down to the center. And what I did is I created an arc length of length R. And because we have R around my pizza slice there, what we define this as is 1 radian measure. That is that degree measure. It's weird, right? But that is how we define this. And that was my third step, very last step here. So 3. So let's see. Are there any questions before I jump into the next part of our investigation? So first off, I went ahead and defined how we actually have 1 radian when it comes to a circle. Okay, cool. I don't see any questions so far, but don't worry, they might come up later. So let's see where we go from here. Let me clear up my screen and let's jump into the next one. So cool. We have this radian length. I'm going to take us to slide 6, everyone. Okay, y'all. Now, we have this definition that this is 1 radian. The next question I have for you all is investigation. How many radius lengths do you think it'll take to cover the whole circumference, so this whole circle? How many of these red lines will it take, right, to go all around this circle? Go ahead and try to like kind of estimate how many you think it will take, and put your number here once you're done kind of making an estimate. Let me know if anyone needs a clarification of what I'm asking in this question. But I'm also going to kind of draw it. So we're imagining that we're taking this and we're just going around again with the same length. I'm trying to estimate, like, I think that's about a radius length. And then we're just going to keep going around and see how many of these radiuses cover the circumference of this here circle. Go ahead and make an estimate, everyone, and then we'll take a look at what y'all think. All right, y'all. So I'm on my teacher's side. Go ahead and enter how many you think. Um, and take a look at, I mean, feel free to take a look at what your classmates are thinking right now. I do see some commonalities. So I see 4, 5, and 6 coming up a lot. So about 4 or 5 or 6 radiuses that go around the whole circumference. We have probably 5 or 6. So if you haven't yet entered about how many you think, please do so. And then we're going to see actually how many do cover this whole circle. All right, y'all. Okay, let's see how many it takes, y'all. Are we ready for the answer? Let's see. Okay, so I'm going to take us to slide 7 and we're going to look at the answer here. Ta-da-ta. So take a look. You could cut. I'll right now talk about this, but let's count. So I have 1, 2, 3, 4, 5, 6, and then some. Y'all see that? So it's about 6, but then there's still a little bit left over. So 6 point something is what it looks like it is. Well, how much exactly is it? Here's a little description of what I'm about to say, but I'm going to also write it down here. So you feel free to read this description, but I'm going to go ahead and make some connections. So we know from the beginning, in the beginning of this lesson, before I started, I said one thing that we should know before we begin is that the circumference of a circle is defined as 2 pi r, where r is your radius. So what that means is that there are 2 pi radiuses that cover the circumference. Well, then what is 2 pi? 2 pi is basically 2 times, and pi is about 3.14. What do you say? It's about 3.14. So 2 times 3.14. If you use a calculator, and I could double check in mine, and again, I did an estimate for pi, 3.14 times 2, I got 6.28. And notice how that correlates to the visual. About 6 and then some radiuses cover the circle. Specifically, it's going to be 6.28 r, or radiuses that cover it. By the way, the specific way to say radiuses is actually radii. I just think if I said radii, it would sound confusing. There we go. So I'm just putting it, so radiuses, but the plural way to actually say it is radii, if you want to be accurate. So it's about 6.28 radiuses that cover the circle. So that means this part right here that wasn't encompassed, that's about 0.28. Notice, see how that makes sense? It's crazy, right? So let's go ahead and think about that. Let's see if anyone has any questions. We're going to be using this information to come up with some formulas to ultimately convert between degrees and radians, because they're both are actually angle measures, and we're going to be able to convert between the two. So I'm pausing for any questions on this particular slide. Okay, it looks like we're set. Awesome. So I'm going to go ahead and take us to slide 8, everyone. So this is where I'm going to make some connections now. So slide number 8. We're all getting dragged there, and there's mysteriously Walter somehow is still on slide 6, but I don't know how that works. And then we have 4 that are still on slide 7, but let's do this. Okay, so slide 8. So we know that 360 degrees now is about 6.28 radians. That's how much radiuses had covered the circumference. So we know that that's true. Another way we could think of this is that 360 degrees, that's one full round around the circle. We know that that's the same thing as saying I went around 2 pi radiuses. Another way to say that is 2 pi radians is how much I went around a circle. So then what we have here is we have that, we can create something now. we have that. Let me type it because I really, really am horrible at writing things out. So we have that 360 degrees is actually equal to 2 pi radians. We have this truth right here. And from this truth, we're going to create some formulas we can use to convert. Before I kind of like use this, what I could do is kind of simplify this formula. I'm going to simplify this formula so it's easier for me to use. What I'm going to actually do is this 2 pi, whoops, this 2 in front of the pi is annoying. Too much numbers for me. So I'm going to divide both sides by 2 to get rid of that 2. When I divide both sides by 2, the 2 will cancel out on this end. And you'll have 360 degrees divided by 2. If you do that calculation on like your phone, 360 divided by 2, that's 180 degrees. And that's going to be equal to, it's just going to be equal to pi radians. So, so this right here, this is going to be the basis. I am highlighting that. So that means that 180 degrees is actually equivalent to pi radians. That comes from the fact that 360 degrees was equal to 2 pi. All I did is I divided both sides by 2 to get this simpler truth that I'll be using. Oh, there's something in the chat, my friends. Let's see. Oh, yeah. How did you type pi? So I actually was typing pi the same way you were. Someone just asked about how do I type out pi. Actually, someone from my last module showed me how. I actually had no idea. So actually, I'm on my Mac. So if you push option and then you push P, so I put option P, I get pi. See if anyone else is able to try that. Yeah, so how did I get pi? So if you're on Mac, I'm gonna just put the directions on Mac. It's option plus you also push P. And that's how you get the pi symbol. So see if anyone else can try it out. If you can't, that's okay. We usually, you could write pi as just pi. Oops, now it turned into like a square thing. There. So you could just write pi if you can't get that pi symbol on your computer. Cool. So yeah, if you could try it out, that's awesome. But basically what we came from this is this truth. Now this is a valuable truth. It's going to come up. What that's going to actually give us is a formula that we're going to use. We're going to be able to convert between degrees and radians with this formula because what we're going to do, y'all, is we're going to create ratios. What that means is fractions. What I have right now is a ratio. I'm going to write this as pi radians. I'm just going to write rad if y'all are cool with that. That means radians divided by 360 degrees. This is a ratio. And we're going to use this ratio to convert. So we have this, or I know I'm writing backwards, or you could write it like this, where you have the 360 degrees on top and then the radians at the bottom. My bar is in the way. So give me a sec. There we go. So what we just have from this connection is we're able to get these two ratios that we're going to be using as formulas. Oh, I'm so sorry. I don't know if y'all noticed that there's an error. Is anyone able to point out the error? I kind of used a different number than I should have. Let's see if anyone notices.
Is it supposed to be 180 instead of 360?
Yes, who said that? My bad. I hear a voice, but I can't see who said it.
It's me.
Who's me?
I don't think it's me helps. Unless
I didn't catch that, but thank you. Yeah, but it's me. Thank you, it's me. I got it. Thank you so much. If you could use the chat, I would love to give you credit. That is correct. That was my typo, y'all. Y'all saw that. I was so focused on 360 that I wrote 360. But the fact was, we simplified that 360 into this nice formula right here. The fact that 180 degrees is equivalent to pi radians. So we're going to use this. So I switched the 360s to 180 to the simpler formula. Thank you so much for that catch. Oh, it was Danny. That was the it's me.
Did my voice sound distorted?
It sounded different, but thank you. I mean, I wasn't too sure, but thank you. Yes, that was a typo. So these are the two things that's going to help us convert between degrees and radians, everybody. Yay. Okay, next, what we have is processing, y'all. So I just talked a bunch. Perhaps some of you are with me, some of you are perhaps like not with me. So let's do a check. So I'm going to go ahead and go to slide 9, everyone. Don't worry, also we'll be recording, so I could send this and remind if you all need the recording as well. But let's go to slide 9, everyone. Let's process check now. We're going to check our understanding. So what I have here is I typed out neatly what I just did in that prior slide so that it's not confusing. So remember, we had figured out that 2 pi radians is 360. 2 pi radians is 6.28 radiuses covering the whole circumference of the circle. That's where that came from. That was equal to 360. But then I simplified that because I divided both sides by 2 to get this nice, in red, this nice simplified conversion formula. We're going to be using that to then create these two ratios to simplify between degrees and radians. But anyways, that was a bunch, right? Go ahead and start to name what is an important piece of information that you see on this slide right here. So in your opinion, what's an important piece of information that you think is important here on the slide? Go ahead and take a minute and then we'll check in. All right, everyone, I'm going to bring us back. Thank you so much for your beautiful thoughts here on what you think was important. So a recurring theme that I see here is A lot of you are mentioning this this first one here in this equation in black, the 2 pi radians equals 360 degrees as being an important piece. And I agree, that is important because if we didn't have that relation, I wouldn't be able to get this more simpler expression that will help me create the two ratios that I need. So I agree. Another reoccurring theme is that a lot of you mentioned this here being an important piece of information. And I also agree because that is important. That is what we're going to be using to convert between the two expressions. Let's see if there's anything else. Some of you found the knowing about the circumference of the circle being important, and how we're going to have equations now to kind of solve something. Let's see if there's anything different. But no, that I think I covered most of what you all had said here as being important. So awesome. Thank you so much for your thoughts. Now, we're going to take a look, and we're only going to be taking a look at the first few minutes. We're going to have to continue this, of course, tomorrow. We're going to finish up. So cool. We talked about the theory about radians, but how do we actually do it? Like, where's our examples, right? So I do have a very, it's a 4-minute video. We're just going to start it. We won't finish it. And then I'll take us to our checkout, everyone. So let's just take a look at a little glimpse on how to actually do these conversions. So let's take a look. Let me play this. Let me turn off my video. Hey, everyone. So we're going to talk about how to convert from degrees to radians and then vice versa. I'm going to go ahead and pull up some slides. And let's go ahead and talk about this. So here we go. We'll go back a bit. So we're going to talk about an example where we need to convert from degrees into radians. And as you can see over here, we have two different equivalent expressions that we can use to go ahead and convert. Now, I noticed that for one, we have pi radians on the numerator position, degrees in the denominator. Or the other setup, we have the 180 degrees in the numerator, and then we have the radians in the denominator position. So we need to decide which to use when we're converting. And it helps to just take a look here that we're converting degrees into radians. That means that degrees needs to cancel out. So we're going to look at these expressions and see which one of these is going to help us cancel out degrees. Well, here's our setup, y'all. So notice how the 60 degrees is going to get multiplied by the expression. And when we do this multiplication, these degree symbols, notice I did convert the degrees into a symbol. These degree symbols will cancel out, and we're going to be left over with just radians. So let me just go ahead and show you this. So this is going to cancel out, and we're going to be left over with just radians. So let's go ahead and see. So notice how I did 60 pi, that's on top, divided by 180. But you also notice that instead of 60 and 180, I just wrote 6 pi over 18. The reason for that is because I know that 10 goes both into 60 and 180. So all I simply had to do is kind of just cancel out these zeros, because I'm basically kind of canceling out the 10 that was in common between the two. You could have just multiplied these out directly and then simplified that. But yeah, so now we're going to go ahead and further simplify this. Notice how we're now in radians. So we've already converted from degrees to radians, but we now need to... Okay, friends, so I'm going to go ahead and pause here, right? Because we're at 11:55, and we're going to be continuing this lesson tomorrow. I do see Arthur, already some folks writing in some questions. Yes, thank you so much. Let me stop my share. We're going to continue this tomorrow, everyone. I appreciate you. Our checkout question is just to think about this new learning that we're doing. All right, everyone. Enjoy today. Bye. Have a nice
All right. See you later.
day.
Bye.
Bye, y'all.
Bye.
Bye. Bye. Bye, everyone.